Okay, hello everyone. So I'm going to go through meshing with Space Systems Thermal, and I want to tackle two distinct problems. One that we've done in class. One is the Poisson's equation here. So we've done this in 1D with beam elements. And the particular example is where this Qx over K, so K, here's the thermal conductivity of the material. I've equated that to this function f of x, where basically there's this heater in the middle of the beam. Okay, so that's one example. And then the other example is this, where we have initially everything, the beam, which is a 2-meter beam, is minus 10. And then this outside end, the x equals 2, is held at minus 10. And then we turn on a heater, and so there's this constant slope of heat moving down from this hot end to the cold end. Okay, so that's the two examples. Now notice this is a 2-meter beam. The other example in Poisson's a 1-meter beam. We can do both of them with the same mesh, simply by changing the extrude distance here. So I've created this 50 by 50 millimeter cross-section beam, and I've made it 1 meter here. So if I edit with rollback here, you can see I've made this beam 1,000 millimeters long. And what I want to do is create a mesh using this length. And then when I change the length to the 2-meter length, I want to be able to see that reflected in the mesh. So I'm going to make an associative model here. So I'm going to do that in this first video, and then I'll show you how to use it in the second video. So the first video here, I'm going to create this associative mesh. So the first thing is I need to create an idealized model. Like, for example, here the scenario is this beam is our current design. So our CAD department has created this design, and now it's my task to go ahead and analyze this with a thermal model. So I'm going to switch applications from modeling to pre and post. Okay, and then once I get here, I'm going to not create an FEM and simulation right away. I'm going to do a new idealized part. So this part here allows me to create this new associative geometry that I'm going to add. So this warning here is, first of all, I have to link to the original design department part. So I'm going to do that by clicking on Wave here. And I'm going to select the beam as my linked geometry. Perfect. So now I'm going to create, so if I go here, you can see the idealized part. So what I'm going to do is go back to modeling and add this geometry to the idealized part. Okay, so this idealized part is now the working part, but it's based on the original design geometry. So I'm in the idealized part. I want to add some points that I'm going to use for my mesh. So I'm going to go into Menu and then Insert and Datum and Point. Okay, and I'm going to use this between 2 points tool in order to locate my parts. I don't want to just define the coordinates, because then that won't make it associative or associated to the geometry of the part. So I'm going to create between 2 points. I'm going to specify this long edge here, and then I'm going to rotate this around and specify the end of this one. Okay, so I'm going to create a point there right at the origin. Okay, so that's 1 point. I'm going to create another point here. Oh, and if I go down here, you can see I've linked the body. That's one thing. I've created a point. Let's create another point. I can actually repeat that here. I'm going to create a point again between 2 points, between this point and this point. So create a point there. Click OK. All right. Now, the other problem for the Poisson's equation, I need to create this region. And again, I want to establish meshing points here. So to do that, I'm going to split the body. Select body zoom. I'm going to specify the plane. It's basically the YZ plane. And then remember that it's going to be between 400. So I'm going to split at 400. And then show the result. That's my split. Okay, click OK. I'm going to do that again. Set my body. Again, here I'm going to choose this body here. I'm going to specify my plane. Same idea. It's the YZ plane. And this time the distance is 600 millimeters. So there it is. And then I click OK. All right, so when I do the mesh, it's going to create nodes or separation at these points so that I can apply a thermal load in this region. I've created points on the end so that I can establish boundary conditions there. Okay, the next thing I need to do is create these associations first. Yes, let's do that. So let's create the line. So for that, I'm going to turn off the solid body. So I hit Control W and it brings up this menu here. I hide the solid bodies, but you can see I still have points. Wait a second. Let me create, let's turn that back on. Let's create those points at the split points. So let's create insert datum point between 2 points. Endpoint at this one and the diagonal opposite. So here it's not letting me choose the right edge. I'm going to choose that edge. There we go. I'll hit apply here so I can quickly create another point. Endpoint at this one. And let's go to, again, it doesn't like me picking that edge. Oops, let's go back. Select all. Let's cancel that one. I've still got my 0.5. Yes, okay, let's create the other one. Sorry about that. So let's insert datum point between 2 points. Right, I'm going to choose, wait for the ... There it is. Let's choose that one. Okay. Go back to the other edge here. And it doesn't choose the right edge. I would to a ... And there it is. Okay, so there we go. All right, now let's turn off the body, solid body. Just Control W and then hide. And now I've got the 4 points. Let's create a line. So insert curve, lines and arcs. Again, make sure associative is turned on, which it is, and then line point to point. So I'm going to choose the first point. Oh, yes, that one. And then I'm going to choose this point. And then I choose this point again. And then I go to this point. This point. Select that. Okay, so there I've created all of the geometry I need. I'm going to now menu, insert, and I need an associative copy. So I'm going to extract geometry. First thing is I'm going to extract those 4 points. So 1, 2, 3, and 4. Apply. Then I'm going to extract composite curves. So I select one, and then it'll select all three because I have the tangent curves option selected. I hit OK. And so I've got extracted points, 1, 2, 3, 4, and then a set of extracted curves. Okay, let's save that. And it will save it to the. Okay, so I've created the geometry, all the geometry that I need. I'm going to turn back on. So let's just here, Control W. We'll turn off the solid. We've got it there. Let's turn it back on and hit close. So we've created the lines and the points that we're going to need. Now what we're going to do is create a new FEM simulation. Okay, it's already selected as my idealized part, the idealized part I'm using, so that's good. I'm going to choose all of the geometry, the underlying lines and points that I've created, or add those to the part. Then, very important, make sure the solver, Simcenter 3D Space Systems Thermal. Make sure that's set. And analysis type thermal. Okay. Okay, and let's quickly create a solution. We'll fix that later once we've done the mesh. Okay, so we have now the four things. We have the original, let's say the CAD department geometry. Then we have the idealized part where we've added the geometry and features in order to do our meshing, our modeling, to apply boundary conditions and so forth. Then we've created a FEM, which is here. Now, to do the FEM meshing, I'm going to turn off, let's say, all the polygon geometries. So it shows me the lines and so forth that we're going to use. And then it's also created a simulation, which we're going to configure in a minute. But let's start with the FEM. First is to create that beam mesh. We're going to select the three lines. Let's move this over. We're going to select this one, then this one, and then this one. Okay, select the three lines. Element size, 10 millimeters, that's fine. Make sure to check off merge nodes. It's going to mesh the three lines, but then create redundant nodes at these points. We want them to merge, we want the software to merge these nodes so that the heat transfer carries on. If we don't, if there's two separate nodes at the same spot, SST will assume there's no heat transfer between the beam. Okay? So we need to do that. Merge nodes. Then the next thing, automatic creation. We're going to make our own, not automatic. We're going to create our mesh collector. Let's make the material. Create a material. Okay, let's create something called aluminum. Let's create a density of 2712, and the right units for that number are kilograms per cubic meter. So make sure the number and the units match. We're going to move, we only need to fill out the thermal properties for thermal analysis. So we switch to the thermal tab here. Again, 155, and the right units here are watts per meter Kelvin, and then 880 and joules per kilogram K. That's correct. So let's move this up and click OK. And then the material selected here. Click OK again. So there's our aluminum. We're going to create a physical property. And that's just saying that there's no additional mass in the beam. And then we're going to next turn on all of the polygon geometry here. And then click on our section manager. And we're going to use this option here, face of solid. We're going to call this cross section. And we're going to choose this initial face. Okay, and then let's choose the vertical axis to be this axis. And then evaluating the section properties. We have, the only thing we really need is area for thermal analysis, which is correct. Okay, so that's that. So now we have the cross section. And then we're going to uncheck radiation. And we're going to name our mesh collector. Okay, so there you go. Let's turn off the polygon geometry again. And let's have a look at what that would look like. Now, this is very disconcerting. It looks like it's only going to mesh one part of it. But for some reason, because we've selected 3, it only shows us one of the 3. If I click OK, now it doesn't look, I can't see the beams. If I come over here to the 1D collector and then go to my mesh and then edit display for the collector and change that to solid and apply, you can see here that it's meshed all of the sections. Okay, so the last thing we need to do here, let's turn this back to done. The last thing we need to do here is create a 0D element. Sorry, that is over here. 0D mesh. And that's because we have boundary conditions right on the end here. So we're going to choose this point. There it is. And it's going to be a lumped mass. We're going to create our new collector for the 0D element. We're going to call this one end mass. Let's call it end points. Oops. End points. We're going to create our own concentrated mass here. It's going to have 0 non-structural mass and have a diameter of just a little 2 millimeters. Oh, let me edit that one more time and call this like end point. Okay, and then also turn off radiation for this and click OK. Okay, let's apply that. So you can see now we have this little concentrated mass. We're going to select the end element here. And again, using the same mesh collector, I create the same concentrated mass on that end. Let's save that, and then I'll show you how to set up the simulations in the next video.